Hello, I would like to do a quick sound check before we start. If you can hear me, please type yes in the questions tab. Great, I'm seeing some responses. Thank you. Hello and welcome everyone. Thank you for joining us today for our webinar titled Explainable AI, How to Make Better Decisions. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Nick Patience is co-founder and research director of AI apps and platforms at 451 Research, part of S&P Global Market Intelligence. And Ben Cox is Director of Product Marketing at H2O.ai. Now, before I hand it over to Nick and Ben, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Without further ado, I'd like to hand it over to Nick.
Great. Thank you, Patrick, and thanks everybody for taking the time today. As Patrick said, we're here to talk about explainable AI and how it enables organizations to make better decisions. I'm going to go over a few things before I hand over to Ben. So some of the survey data that we have here at 451 Research around machine learning adoption, talk a little bit about the scale and complexity, increasing scale and complexity of machine learning and AI implementations that makes this an ever-heightening issue, dive into explainability and bias, and then talk about the benefits of explainable AI before handing off to Ben. I've been looking at this space for a long time, for 20 years really, since we started 451 back in 2000, and so it's part of it. It's a key part of our coverage area, and I work with all the analysts across 451 Research to uncover use cases and understand the impact of those use cases and any constraints on those use cases and things like that. So I thought it'd be good just to start off with, I'm not a big fan of definitions, but I think explainability is still something which is not quite, not necessarily that well understood. So we're talking about the need for decision-making systems that are driven by AI to be explainable to users in terms that humans understand. That's essentially what we're getting at. This is our definition. Others may have a slightly different one, but I doubt it differs that much. And then bias, the concern that these decision-making systems will impact groups differentially or unconsciously, reflecting some sort of systemic bias in the data, bias in the developers, kind of goes hand in hand with this. And these are both part of the overall space known as machine learning operations or ML ops. And you can get other variations in this, including responsible AI. That I think Ben might talk about some of the links between responsible AI and explainable AI. But get that out front, and then we can move on to talk about the other issues. So in terms of adoption, we do a couple of surveys a year called Voice of the Enterprise AI and Machine Learning. One's focused on use cases and one's focused on infrastructure. And when we do these things, we always ask organizations, are you using machine learning now? Do you have it in production? Do you have it in a proof of concept stage? Or do you not have it yet and you plan to within the next 12 months or so on and so forth? And here you see the numbers for this year and last year where we're asking these questions. And obviously, as you'd expect, these are growing. So adoption is on the rise. So 29% of organizations told us to have AI in some form. Machine learning, really, we're asking about in production, and 28% in the proof of concept. So you can total those up there in the red numbers. And large drop in the numbers that have no plans to use it or not being aware of any plans. So as you say, enterprises are becoming increasingly aware of the benefits that this can bring to their organization. Now, this is a kind of binary question. It's, are you using this? Are you not using it? A couple of years' time, 3 years' time, we probably won't ask this question because the answer will be we're using it. And we could be using, these people here could be using, they could be data scientists building and training their own models from scratch, or they could be buying applications with machine learning built in, whether it be a security application or a CRM application or anything like that. Because as you know, I'm sure, machine learning can be put to sort of more or less any use case in any part of the organization and has an impact up and down the technology stack. Digital transformation is still, and even probably more so, accelerated this year as the kind of lens through which major technology projects are being looked at. And so we always ask, how important is this? Is AI and ML as part of that digital transformation? As you can see here, 47% and another 47% essentially say it's either very important or somewhat important. So it's important, I think, is a key takeaway from this slide. And why would that be? Well, a lot of digital transformation efforts in the last 2 or 3 or 5 years really have focused on the benefits of uncovering insights from large volumes of data that previously have not been exploited, usually around unstructured data of various kinds. And how do you do that? Well, you use it, analytics driven by machine learning is really the only way that we've actually been able to do that. We've had this kind of need for, as long as I've been an analyst for 25 years, this has been an issue. But really is only in the last 5 years where people can actually do anything about that. So this is why machine learning is so integral, we think, to digital transformation, and more importantly, the end users that we survey think it is as well. Now, machine learning models are becoming, integrated into DevOps. So this is kind of an illustration of how, I wouldn't say it's mainstream yet, but edging towards mainstream, machine learning is becoming in terms of the software development process. So here you have a few industries here, highlighted. But overall, you have a third of organizations, we surveyed in this particular survey, saying they have a formal strategy and actively taking steps to integrate machine learning models with their application development efforts, and another 41% in the evaluation stage. And obviously it varies, these things always do, in terms of industries. Would not surprise you, I'm sure, to see software and financial services are ahead of manufacturing and other areas, but there's still strong numbers in all industries. We think, this is a key point that heightens the need for explainability, because as machine learning gradually becomes part of the regular software development process, it can only really do that and become part of that as long as it has explainability features, which are similar to kind of analogous rather to the testing processes that go on in application development and have done even before DevOps came around, when we were in waterfall environments. But now this kind of constant testing, continuous improvement, these kind of areas, again, it's analogous with part of the continuous improvement process of machine learning models is being able to measure their explainability. Now, I said at the top, we're going to talk a little bit about why this, it's an issue now and will become even more of an issue. And part of that, integral to that really, is the scale and complexity of machine learning. Why is that? Well, data is a key part, and we mentioned unstructured data briefly, but breaking it down a bit, this is the kind of data types people are using to feed their AI workloads. By feeding AI workloads, I mean build and train machine learning models. Really, that's really what we're asking people here. Structured data, that carefully curated structured data that we spent many decades nurturing and curating, is obviously key and is seen to have I guess a high proportion of value built into it. But the semi-structured stuff is where the action is, as it were. That's where the uncovered, the uncovered insights lie. And it could be semi-structured data, there could be log files, could be unstructured text, could be unstructured media, rich media, bit of an old-fashioned term, rich media, but obviously we mean images and videos essentially, but also audio. That's far more complex a problem, obviously, than text data or log files, or as you move back up that list, and that presents another challenge around explainable AI. You need to be able to understand what's in that image or that video before you can then interpret it and then discover whether there's any biases involved or anything else like that. So it's a much more complex. If you got rid of the bottom 4 there and left with structured data, maybe a bit of semi-structured data, you kind of have the application development process over the last sort of 40 years, really, which largely ignored most of the other types. That's no longer the case. And the reason is because we have machine learning and we have advanced analytics to make use of that and actually uncover the insights from that kind of data. So not only are the data types more complex, but as you'd expect, the data volumes for training and inference are growing. So training the process of building and training a model, and then inference, the process of getting predictions out of that trained model using new data. So these are the anticipated relative changes in data volumes for these workloads. As you can see here, small portions say significant increases, moderate increases. There's increases across the board, slight increases. So you're looking roughly at sort of 70 to 80%, even more than that in some cases. See these volumes increasing for these two parts of the process in different ways, I'm sure, but and using different kinds of data, but they're increasing. That was the kind of relative change. These are the absolute numbers. I'm not saying these are definitive across the board. These are definitive in the surveys that we do with people who know and understand their machine learning process in their organization. And so we're asking them here, what kind of size are the volumes for these workloads? And you see there around the 500 and 909 petabytes for inference, and you see the training workloads, each one slightly lower. But currently nearly 44% use or plan to use, so either have it in production or POC, more than a petabyte of data to build and train their models. And we find overall 54% use more than a petabyte for inference. This speaks again to the kind of complexity issue. Another way of measuring the scale of this is in terms of the number of models organizations have in production or in POC. Now, you may think this is quite a hard number to come across, and it can be in certain organizations. But it'd be surprised at how many kind of companies in areas, in industries where you wouldn't think particularly cutting edge in terms of technology adoption, such as manufacturing and healthcare, are becoming acutely aware of whether they have 6 models in production or they have 50 models in production. And then there's obviously some that have massive amounts, thousands, or if not tens of thousands, but they are very much the extreme. When we kind of net out this data, organizations on average have around 88 distinct models in production and another 59 in the POC stage. Roughly a third of organizations had more than 100 distinct models in production. This is only going one way, and we'll change the scale on this, and I'm sure next time we do this survey, because the models are growing. And this is again talks to the scale and talks to the complexity of the machine learning environment. So we talked about what explainability was at the top and what bias is. So let's dig into this a little bit more and see what organizations think in terms of how important is this stuff. Is this actually important, or is this something they can safely ignore? Well, our surveys say they are certainly not going to safely ignore it, can't safely ignore it. 92% say it's either somewhat or very important. And so that's as projects move from POC and production, we think explainability becomes even more paramount when you look at these numbers. So it's pretty clear that organizations understand that this is an issue. Some are doing something about it. Some are buying tools for it. Some are building tools for it. Some are relying on other vendors to do it for them. And so, but it's definitely a hot button issue. And you're on this webinar to understand about this, and I think you're in the right place because it's definitely a crucial issue. We thought at the beginning of this year, before everything else happened, that ML ops would be possibly the most important trend in machine learning, and I think that has played out in addition to everything else that's going on in the world. And you can see it here in these numbers. But it's not necessarily that simple. It's a desired goal, but it's certainly seen by some organizations as one of the barriers to adoption. So we ask end users we survey, give us a list or pick the top 3 of the most significant barriers to adoption of machine learning. And budget limitations came top at 31% when we did this. But 24%, just to give you an idea of the scale, 24% of respondents selected explainability as one of its most significant barriers. I think it was 3rd on the list. And there was about another 6 or 7 issues below it, including like lack of skills and buy-in from senior management, those kind of issues. So that gives you an idea. It's a mix of technical and operational issues. And it varies by organization. So 25% of healthcare organizations we surveyed selected model explainability, 34% of technology companies selected it, which may surprise you a little bit. And then 27%, so above the kind of the average here, with more of companies with more than 1,000 employees selected it. So lack of explainability is hindering machine learning endeavors unless we can do something about it. I know we can, but it's certainly an issue. And bias, we mentioned earlier, bias testing is something that is not yet a universal process. So we ask organizations, are you testing for AI applications for bias? 53% said yes. I think that's probably a little bit high, if I'm perfectly honest, even though it's my data. But I think it's a little bit high. And then it's kind of related but similar question: what proportion of the applications that use machine learning do you actually test for bias? And you can see there that the 13% said we do it for everything, and 16% said we did it for 3/4 to more or less 100%, and so on and so forth. But it's certainly not a universal process. And again, like a lot of these questions, we expect these numbers obviously to go up in coming years, but they need the tools and applications to be there to make it happen. So I'm going to hand over in a minute to Ben. Before I do, I just wanted to look at what we see as some of the key benefits of explainable AI. First off, and there's others as well, we can talk about them, but better customer experience. So trust is a key issue. If customers trust your AI is making fair decisions, they're more likely to remain loyal to you. The inverse of that, of course, is lose that trust and you're in grave danger of losing the customer. Regulation readiness, and I know this is something Ben can talk about a bit more. There are already regulations around these kind of areas such as employment law. They already exist, but there's a lot more regulation of AI coming at various levels. We think is inevitable, and explainability would be at the heart of that. Why? Well, if you have if we have a sit round table, we'll sit round tables again soon. When we do sit round tables again soon, and one side you have the developers, and the other side you have the regulators who may have law degrees and things like that, but they're not technical people. They need to be able to understand why your model is making the decisions it's making in language that they understand, and they will be you increasingly the use of AI will become more regulated, so there'll be more need for that kind of thing. Aids talent acquisition. That may seem a little bit strange, but think about data scientists who can be pretty picky about where they work at the moment. They are obviously highly valued people. There's more of them around. The scarcity issue is less acute than it was a couple of years ago, but it's still pretty acute. But those kind of data scientists and other AI professionals, machine learning engineers, they don't want to work on black boxes. Black boxes, obviously, where you can't tell why the model is making its decisions. But it's not good for their career to be in those kind of situations. And so, they can aids talent acquisition or aids talent retention as well, I should say, because it's important to keep these people. They're expensive and they're difficult to get. Better security. That's the ability to detect anomalies in model behavior. How would you do that if you don't know how the model works in the first place? Again, explainability is a key thing. And the democratization of AI is a bit of a cliche in the industry, but it's true. Going back to that scarcity issue of data scientists, we need less technical people to understand how the AI works and how they can suggest improvements for it. Again, if they can't understand how it works, then how can they ever suggest any improvements? So there's a few benefits, and that's me. I'm easily findable at S&P, but I will now kind of hand over to Ben. So Ben, you want to take over from here?
Yep. Let me share my screen. Do you want to end presenting and I can?
Do I have to do that? Yeah.
Or
screen share. There we go. Okay.
Okay, 1 second. So I think that this is really important for a lot of reasons, right? I think we've given a lot of these talks, and I've talked to this area a bunch, and it's hard because there's not always data to it, or information to sort of back up the fact that we believe that this is a really leading or growing area. So if you can't see my screen, give me a shout and I'll try to fix it. But what I will say is that having this survey data is really, really important, right? We spent a lot of time over the last few years saying people want to understand their models better, and because companies tend to be pretty private, customers tend to not want to talk about what they do or do not know about their models. It's really hard to give you data points. So thank you for one, adding some quantitative numbers to that, because I think it's really important. I start with this a lot, but I think it's really important to set the table, right? You just ended with a bunch of very critical benefits. And I think a lot of people in this group will have seen some of these headlines over the last few years, right? And I could probably refresh this list from this past week alone, right? This happens constantly. And I'm not going to assert that any of these specific, headlines is, an AI algorithm going rogue. But if you had strong explainability practices, you probably would have not found yourself in this situation. So there's this big risk that companies take on with machine learning, because essentially you're bringing technology with agency into the mix. And it's important to understand and do what you can in order to mitigate the downside and the tail risk of that technology, right? And it depends on your company. It depends on how fast you make decisions with machine learning, how material are the decisions, how bad is the brand risk of that specific project should it go wrong. There's some use cases of machine learning that aren't that risky, right? Like that don't, that add an extra data point for an analyst to make a decision that doesn't really impact, net customers. But there are some AI instances that have dramatic impact. So one thing that we talk about at H2O is we kind of call it the parent bucket of responsible AI. And, what's great is that, all over the industry, there's different terminologies for this various field and the subcomponents of it. To us, when we started out on this kind of journey, explainable AI was really the ability to analyze a model after it's been developed. So what I'm going to do in this presentation for the remainder of the time before we open it back up is talk about what are the methods that we have to analyze and explain models after they've been developed. But so you can get some idea about what else we think really, really matters in this space is, to Nick's point about bias, we kind of talk about that as ethical AI. Our downstream consumers, customers, users of your machine learning potentially being discriminated against or disparately impacted against by that machine learning model, right? Interpretable machine learning sort of harkens back to, okay, what are more interpretable model architectures that you can kind of analyze better, right? Like a generalized linear model is inherently more understandable than a deep neural network, right? That's not crazy to assume, right? So secure AI goes to Nick's point about privacy. Models can be hacked. Models can be not secure. You can do, the Microsoft Tay example is a data poisoning case where they put a machine learning system live and then the Twitter community came in and poisoned it with all this bad information and turned this bot into a really unusable thing. And then human-centered ML, and that's just kind of the human-machine trade-off of how much is being done by a human, how much is being done by machine, and how can you get humans in the loop to make your process more secure? Because I think by nature of artificial intelligence and artificial general intelligence, the industry got really excited about this idea of we're doing tasks that are replicating human tasks better or worse. And so you lean into this idea of, oh, let's take humans out of the loop, but we don't think that should be the case, right? So some of the points that you made were really good, and some of the survey data about what are the biggest barriers of adoption or risk, and a lot of times it's the expertise, a lot of times it's PR risk or regulation or cost. But with machine learning, you have a lot of additional risks that you don't really often consider, and that's what is your automation plan? How do you plan to parcel out rote redundant tasks to a machine, but keep the profit driving strategy and kind of customer relations roles with humans? And then what are the ethics and bias considerations? What's happening to your risk management profile by taking on these AI algorithms? What's your cyber security risk, your privacy risk? And then the big technical debt component, right? Like machine learning and data science, since it's coming out of statistics, technical debt is not something that's discussed enough that you, like the way that you would with typical software. And that's kind of an oversight because machine learning does carry technical debt. And you have to think about, okay, the way that we're building this model, what kind of costs are we creating for ourselves down the road? And what kind of upkeep, monitoring, maintenance, continuous integration, continuous development do we need to do alongside this machine learning model? So with that being said, I think you brought up a great point earlier about trust. And there's this like bifurcation that exists in companies where you'll have leaderships who kind of, you know, laser scope in on, okay, what's the risk of this model? Just tell me the risk. But you have the data scientists, to your point earlier, you know, who deeply care about the trust in their machine learning models. And to your point about, you know, ability to hire, a lot of data scientists want to work at technology companies that they feel are doing moral things with their machine learning models, and their models aren't perpetuating, you know, our worst selves, right? So it's really important to know that these are essentially the same thing, or it's a flywheel effect. You know, the more you can trust your model, the more you understand the risk. The more you understand the risk, the more you can trust your model. It's not, you know, rocket science, but it's something that gets overlooked because with data science and the complexity of it and some of the ways that it's come up in industry, there's often seems to be this disconnect between leadership and data scientists, but they want the same thing, right? So let me kind of talk about where we see explainable AI. So what we see often for explainability companies diving into explainability is that they think that, you know, that they take explainability as this post-hoc model review step, right? And there's a lot of work in that space. And I'm kind of going to go through what we do and the practices that we think are the best. And then I'm going to kind of take a step back and, you know, go a little higher. So in your typical model development lifecycle, right, you've got your like data prep, loading, feature engineering, exploratory data analysis, you've got model training, and then this is where you kind of parcel in the review for explainability, fairness, interpretability. And then you have your, you know, deploy it, you've got ongoing review, and then you've got your fail check, right? So that's not that crazy of an addition into a data science lifecycle. But in the post-hoc analysis, here's what we do, here's what we like, right? So I think I saw some questions in the chat about how do you check for bias? Now, this is two-pronged because there's algorithmic bias and then there's data bias, right? So sometimes your data will just be coming in from, depending on how it was created, whether it was created under, you know, less than ideal circumstances or you kind of collected it suspectly, the data might be coming in with a bias, you know, inside of it. But what you want to do and what we like to do in this is disparate impact analysis, where you're essentially checking, you know, the adverse impact of one category, say it's male, female, or ethnicity, or age, or education level, or marital status, and you want to see if one of those categories is being treated disparately from another, right? This is a really good way to check, and this is a lot of the latest and greatest of what people are doing in financial services or highly regulated industries. And now there's a couple different flavors of this, right? Like there's a couple different ways to calculate it, which we kind of continue to work through and write papers on. But there's disparate impact, disparate treatment, and then adverse impact. And all of these sort of just go to the same point. Are people in your data set being treated unfairly with respect to another category, right? That's just, it's a simple concept. And this is kind of the latest and greatest method. Shapley values is probably familiar with many folks, but I'm sure you understand the idea of feature or attribute importance. Shapley values kind of runs that calculation over the entire data set on average, so you can get a much more refined understanding of which features are important at the aggregate. Because the way that models run calculations and you get feature and variable importance, you know, depending on how that model was compiled or how the data was piped in, you might get different answers. So Shapley values runs the calculations to create averages over global and local universes to determine what are the most important features to the model. K-Lime. K-Lime is a little more complicated. Some of the next few methods are basically taking a complicated model and fitting an interpretable model to it. So can we create a linear model that's a surrogate model of a more complex model? I don't want to spend too much time here because I think these other ones tend to be more important. Surrogate decision tree is another really good method, right? So you've got this model that might be an ensemble, might be kind of complicated, might be really hard to like mentally intuit what's happening. Surrogate decision trees enable you to create a decision tree that essentially highlights the paths of the decisions that the model made. So it's really good, you know, in the example of this Titanic data set, you can see that if you were a male in a cabin, you know, with a certain age, you might be a very high candidate that you might die on the Titanic. That's like what the prediction model would say, right? And this works for churn. It's like, you know, are you a certain age? What is your tenure? And it kind of traverses the tree to give you a visual demonstration of how that model is using those features to make a decision, right? This is a really good visual method that I think people really, really can appreciate. Partial dependency plots enable you to see what the average, you know, increase or decrease on the ultimate model prediction that certain sub-features will have. So this can be continuous, this can be, you know, categorical, but essentially how are females versus males being treated by this model on average? And it gives you a really good, you know, and you can see over time in like churn models that the more tenure you have, the less likely you are to churn. You'll see this kind of negative linear path. And this is a really good way to understand, you know, for each variable feature, how important are certain things. And I'll stop there to just make another point. One thing that happens in the explainable AI space often is companies, you know, providers, consumers find one explainability method that they like SHAP values or feature importance or PDP, and they think, okay, this looks good, we're good to go. But what I'm going to assert is that you should do a lot of different explainability methods and see if they tell the same story. Because sometimes you'll have examples where you'll be able to understand the model, but you'll learn very clearly that you understand it quite well, but you know that you cannot trust the model. Because certain of these explainability measures and metrics will kind of tell different stories. And that's really, really important to understand, is that if some of these metrics start telling, you know, conflicting ideas, it's important to take a step back and start from the beginning, or start to analyze what's causing that. Sensitivity analysis is a really common one, or what-if analysis. There's a lot going on in this image, but it's essentially the concept of if we were to change, you know, various features, like in this credit card example, if we would change the bill amount or the pay amount for all or for a single line item and then refresh it, how would that change the overall predictions of this model, right? If we change the bill amount to $10,000 for all of these credit card customers, likely the model would start to predict that a lot more people will default, right? And so it's the ability to kind of tinker with your model and say, well, in this certain scenario, what would happen? And that's a really important tool. And then so exportable, so when I showed you the surrogate decision tree, what's essentially under the hood of that is a rules-based system. And a lot of companies necessarily aren't ready to have a full service machine learning, you know, living, breathing model under the hood. But a lot of them are comfortable with the idea of, let's make a really good machine learning model, let's create a rules-based system based off of that, and let's use that. Like a lot of companies are, once they've checked that model out, they feel comfortable with it, they're okay with those rules. So it's about taking that kind of surrogate decision tree and exporting it out and loading it into rules-based systems. This is really good for things like anti-money laundering, fraud, financial crimes, where a lot of the typical flags are based on rules-based systems. And this just allows you to really define what's causing those rule-based systems. So I'm gonna pull back again, like I said. What we kind of think at H2O is that explainability, interpretability, and fairness should exist at every step of the data science lifecycle. I think this is really important to articulate, because what you want to be able to do is at every step of your process is to think about what could be causing a lack of explainability, what could be causing fairness issues, what could be causing bias to creep in, right? And so, you know, there's all of these various toolkits, you know, just in the data prep phase that you can start to understand your likelihood of potentially incorporating bias into your model, right? Like outlier and data quality, target and population imbalance. You know, one of the examples that we give a lot in the credit card data set is it appears to be biased against one of the marital status categories, which is other. And it's not because, you know, other is necessarily a risky attribute. It's just the fact that it's a low quality and a low volume data point. So a lot of times disparate impact or, potential bias will be the result of just population imbalances. And that's important to know. You can find that up front. You never even have to get to the post-hoc analysis to discover that. And then so before you even started to get to what did our model do, you can constrain the universe of feature engineering. You can be very calculated about how you do hyperparameter tuning. One of the biggest ones that I think is super important is monotonicity constraints, right? Monotonicity across feature importance is a really good thing to make sure a model didn't get way too creative about what the feature's importance are across that feature category. And then there's another aspect here that I'm going to kind of talk about a little more is white box modeling and adversarial testing. We've gotten to this really cool phase of machine learning too, where now we're working backwards and saying, okay, with our favorite deep learning models like deep neural networks or GANs, can we make them more white box? Like, can we make them more transparent as a modeling method from the start? And then there's a whole universe where you can create models, adversarial debiasing, where you're creating a model that basically says my primary objective is accuracy or AUC or, log loss, whatever. But our secondary metric is fairness or a low average disparate impact. And so from there, you can kind of tell your model, hey, I want to keep an eye on this fairness across protected feature stuff. And that's really, really important. So I talked a lot about the post-hoc analysis, and then also on sort of the output side of this, once you have a model in production, what are you doing to monitor its fairness? Are you A/B testing? Are you checking feature drift? Are you checking Shapley drift? Because if you have a model in production, obviously you care about accuracy over time and the frequency of like yes or no's over time, but how are your feature importance changing over time? Are you becoming more fair or less fair over time? And these are really, really important things to keep in mind because the machine learning development lifecycle, it's software. There's a lot that goes into it. So the last two things I'll kind of talk about, well, there's a couple things, but so I talked about white box models, and one of the best, models that we really like, in recent years is generalized additive models, GAMs. But GA2Ms essentially adds in an interaction term. So you don't need to understand the math here. The idea is just that when you can add in an interaction term and say, okay, we care about accuracy, but we also care about these certain features, it allows you to create nice visuals to understand why certain things are happening. And then more specifically, explainable neural networks. This is something that we worked on heavily. Wells Fargo worked on heavily. There's been a lot of good work in this space. It's the idea of let's take a deep learning model and let's add, some sort of understanding to the subnetworks, to the hidden layers, to the epochs. It's really important because we can add some explainability components to this, and it enables us to use these, these deep learning models, but with some transparency included. So I want to leave time for questions, but I threw a lot at you, and a lot of people then ask, okay, well, like, how do I do it? So we wrote a book called Responsible Machine Learning, and the gist is this. It's a multi-phase process that it's pre-hoc, it's post-hoc, there's line of business implication, but this is kind of our proposed architecture, right? I don't think anyone seeing this would look at this and say, this is outlandish. There's no way we would ever do this. It's very akin to what banks go through for model risk management. And a lot of the things that we add in, or we propose should be added to a data science workflow are not that overweight. They don't cost that much. They don't take that much time. So, doing fairness, privacy, security, pre-processing, keeping it to a constrained universe of fair, interpretable causal models, doing model debugging, finding root cause explanations, doing discrimination and remediation testing, and then some really good points too. Some things that really help companies get this right is the right to appeal and the right to opt out tend to do very, very well. But once you get to the end of this life cycle, it goes back to the business, right? You're creating new data, you're creating new predictions, and then there's all lines of business sort of have some accountability here to really, speak to the quality of their data that's ultimately piping into these models. And so you see you have a lot of teams in the mix here, and it's kind of a team effort, right? So we also propose this architecture for explainable, responsible machine learning, and having this kind of architecture will enable you to make sure there's appropriate checks, balances, accountability in the cycle to make sure, things aren't just getting overlooked, because a lot of companies applying data science right now, if their model goes completely haywire and makes extremely sexist or racist decisions, there's not necessarily somebody that's going to be held accountable for that. And it's not just accountability, it's just there aren't that many companies that are doing a really, really good job of creating a linear workflow for their data science process. And by doing that, you'll really open yourself up to creating like a lot more value and just a lot less technical debt. So, some of the themes that I'll talk about here, and then we'll open it up for questions, right, is decrease. So there's the ability to, within the model specifically, the more you understand it, the more you can actually decrease the risk that the model takes on, right? What that's also doing is the simple you can make your model, you decrease the risk of, anomalous situations hurting you. COVID was a great example. We had this really long bull market that was very smooth, more or less, in jobs, in employment, in economic numbers. And when you get a COVID-like scenario that's like a 100 sigma event or whatever it is, a lot of models start acting very weird. But the models that hold up the best are the most simple models and the least overfit models. So when you can find how accurate you can get, but also simple and explainable, you create a more resilient risk-off business. Transparency is kind of a no-brainer here, right? Like a lot of problems in data science adoption was really cool in-sample results and excitement. But once it became, okay, now we've got to pitch this to leadership, there's kind of a drop-off where we're not going to do a good job communicating what this like principal component analysis is technically doing, and it just doesn't land at the C-suite. So being able to increase the transparency and be very clear about what's going on and why the model's coming to the conclusions that it is great for the adoption curve, is great for the innovation curve, and it's really, really important. Prevent technical debt. I talked about this earlier. If you build a data science organization that's basically like popsicle sticks and scotch tape, you're only in for a world of hurt later on when you have to really, look in the mirror and say, how did we build this team? Do we know who's doing what? Is there governance and transparency across the data science projects and investment that's happening? Early on, there was so much money coming into this space, and there still is, but there's a lot more need for accountability and ROI and measurable results and impact and time to value. So you're doing yourself a favor by starting from a place of responsibility and explainability. You're setting yourself up for success long-term, not just short-term, let's scrap together models as fast as possible. Gain deeper value and insight into your data. One thing I want to call out here is like explainability is not just a defensive metric. Or a defensive measure, when you do explainability exercises and you get all of these exportable rules, all of these, enriched data of what are the feature importances, what are the SHAP values, what are our predictions, you're kind of getting a nice metadata, right? Like, so banks started from a place of, okay, let's analyze customer transactions and see what the patterns are. But then once they went digital, they realized we actually want to see click-through rates. We want to see how long people are hanging out on certain screens. We want to do real omni-channel analytics to get an idea of what the metadata under the surface is saying about our customers. Where are they going? What are they looking at? What is grabbing their attention? I would make the case that explainability is that same metadata for machine learning, right? You're creating a lot of tremendously valuable insights that you want to see over time and that you want to use those to make predictions and decide where your business is going. So there's a tremendous value, not just reactionary, but it's an offensive measure, and I think it's a great one. And then increase agility and resilience. The reality is, machine learning is a great concept because it lets your company be sort of evolutionary or adaptive in the way that new data comes in, your model learns, your model gets better. But you don't want to do that with overfit models. By having explainable measures, or explainable models, you're going to be more resilient and quick to respond to certain things because you're going to catch things as they're happening. If you have an eye on explainability and fairness, you're going to know when your model starts trending in a way that it's starting to flag on certain groups are being disparately treated, or these models are getting less and less intuitive from a feature importance standpoint. And that's really, really important. Like, you want to be able to adapt to like the business climate. And I think that's, you know, a critical thing to have. So that's all I got. I think we can open it up for questions. Patrick, I can't see the chat, so let me know what questions you want to dive into.
Sure. No, we got a number of great questions here. There's a couple too that kind of fall into the same question category. So let's go with, what is you know, a type of test for bias in machine learning, and more so, how was bias tested in, and I believe they're referring to Nick's findings, and according to regulations, like how do they test for bias? So just bias in general, how is it being addressed?
Yeah, I mean, to me, it's just disparate impact. That's really what's kind of leading the charge right now, is disparate impact analysis. And there's a couple ways that this gets kind of categorized in legal or regulatory terms, and I'm not a lawyer, so please do not hold me to this, but it's kind of disparate impact, disparate treatment, adverse impact, and then adverse action. And I think that it's just really important to know that, like, this is a method that's being used at major banks. But what's important to know is that this isn't just a banking thing. You know, companies, you know, California just passed the CPRA, which is kind of a right to explanation and a right to opt out. If I understand it correctly, again, not a lawyer. So now non-financial firms, their feet are being held to the fire about what their machine learning is doing and how is it affecting its customers. It's not just in a credit lending, you know, example, or a loan offering, or, you know, a loan decision. It's everywhere now. And if you're a company, you should really consider disparate impact or some of the fairness metrics that are out there. That's my thoughts.
Okay, great. Next question is, what is the current state of the ability to audit explainability? Highly regulated industries require this, so I'm just curious about the panel's assessment and what more may be needed in this area.
I mean, you want to take a stab? Yeah, like you go and then I'll follow up.
Yeah, I mean, I'm not a deep expert in the auditing part of this. I mean, I think it's obviously, yeah, we certainly see. Well, I don't know. We certainly see some of the auditing companies that are, you know, that have more, technical acumen than some others, trying to add this to their kind of portfolios of services. If that's the kind of thing you mean. At the moment, I don't know explicitly what kind of tools they use. I guess it does depend on what tools have been used to build and train the models to start with, to a certain extent, as to how easily they can get in there and actually, see how right from the beginning of the process to the delivery to the customer or employee or whoever it is. So yeah, that's about as much I can tell you at the moment. I don't know if Ben has more.
Yeah, so I wrote a paper. I don't know if it's in the chat, Patrick, but it's about themes and commonalities across various regulations in the industry. So there's one world where it's finance, and the current is SR 11.7 model risk management, and it's kind of classic statistical methods and asking for model documentation. So documentation is really critical. Like, you really want to be able to document why you built the model, what you tried, what the accuracy was, what are the important features, what did you not include, what was the data quality, like these kind of classic financial requirements. But the FTC in the United States has put out guidance over the past few months that kind of dives into this. And it's like, can you explain why your model came to the conclusion that it did? Were people, offered various rights to explainability or opt out? Do you know that your model is transparent or fair? And so we're getting to the place where regulators that are not just financial in the United States are asking for companies who are applying machine learning that applies to customers to be able to explain, tell them that it's fair. And then that comes back to all of the kind of metrics that I proposed here, because these are kind of the leading methods. Now, what's also happening at the same time is policymakers and regulators are reaching out to industry experts because they want to start putting this in formalized terms, right? I don't know if there's a regulation that says Shapley values are what you need, disparate impact, we need to see those numbers, but they do ask the questions that those features answer, or those metrics answer. So what's happening is that because machine learning and AI is so new, a lot of various governments have put out guidance on, okay, it needs to be private, secure, fair, legible, transparent, explainable, and all these things, but they haven't necessarily dialed in yet to what are the exact metrics. So from an audit perspective, a lot of times what will happen is, you'll just get asked, can you show us the model documentation? Can you show what kind of model risk management it went through? And that sort of thing. And that's why we are sort of recommending these as the leading methods for how you might, handle one of those situations, right? Because for SR 11.7 and model risk management, they use some more classical statistical analysis methods, but machine learning has its whole host of new considerations, and that's where the things like disparate impact and SHAP values and PDP and stuff come in. And that's where I would look. And every week there's a new paper on a new type of Shapley value or a new way to do fairness. But SHAP values and disparate impacts have really been, strong. And so, model management and understanding why the model did what it did, but then also documenting it should be the two core pillars of how you plan to respond to an audit, so to speak.
Ben, can I just ask you, do you see that's the responsibility of that chief model risk officer that you highlighted there? And I'm curious how prevalent you find those. Is that a financial services? Because I must admit, I don't come across them much. Is it a financial services only thing, or are you seeing that across other industries?
No, it's what we propose.
Okay.
We don't think that every company should have a chief model risk officer. They definitely, not all companies will, but if you're a company that's heavily dependent on machine learning, it's really something, and you're a larger company, it's really something that's worth considering because, regulation already exists, as you mentioned, in things like employment law and lending and things that aren't machine learning by nature, but machine learning is being used to make those decisions. So regulation already exists for that type of edge case, but it's happening where that all, Europe just put out new guidance on what the correct, machine learning policy might be. I haven't had a chance to read it, but things happen very fast. And if I'm a company that's operating, has a lot of models in prod or a lot of POCs that are ready to go live, I would take a step back and strongly consider, should an oversight agency, whether it has to do with employment, whether it has to do with the Trade Commission, whether it has to do with, financial reporting, understand that if somebody comes and says, okay, we see that you're using machine learning for this, can you explain how and why? You should be ready for that conversation, and that's the role I think a chief model risk officer should play in terms of responsibility to oversee that process. Yeah, we understand that not every company can have an entire business unit on internal risk governance and compliance, but these functions should be managed and overseen, or else, in finance, if a new reg comes out, these companies dump billions into organizational readiness and to make sure that continuity can, exists once that cutover exists or occurs. So companies should just be prepared, right? A lot of regulators, whether they're financial or otherwise, are asking, okay, you're using machine learning, but how and why, and is it violating other laws that are unrelated to machine learning in the first place?
Great. All right, so this next question is asking, do you use BISG or some other predictor to complete the disparate impact or treatment?
I'm not sure to answer that one. I don't think so. I'm not familiar. I mean, the two main metrics that we use for disparate impact are SMD and ME. So those are our two bread and butters. But I don't think we use BISG.
Okay. how effective or representative is converting complex neural network models to decision trees?
Yeah, that one's trickier. I know for us, the way that, so I don't have a great answer. I know that for our universe of models that we really, really like, are the XGBoost, light GBMs, and those kinds of like boosted trees, which on tabular data perform the same as neural networks. And Kaggle just released a survey about what's your go-to modeling method. And, you know, the boosted and bagged trees of GBMs and XGBoost are still way, way ahead of deep learning. And they're very easy to get into surrogate decision trees. Maybe with XNNs, it's more possible, but I actually haven't worked that problem, to be honest.
All right. Can you comment on prescriptive analytics and counterfactuals? Is this the right way to go to be able to simulate scenarios and define strategies to achieve specific goals?
Oh man, that's kind of a heady question, and I'm not sure I'm necessarily the best one to answer. I feel like when you get into the counterfactual world, you get into some like real causal statistics or causal inference, and that's just a pretty tough one. I'm not sure if I'm a good answer here. These are really tough. You guys are good.
Okay, how do we test an AI product for bias, fairness, and correctness when no demographic information is asked from participants using it? In this case, or in case demographics are recorded, we could have adjusted for these covariates, but what if not?
Yeah, so with that one, so this is where like, I think that domain expertise is super critical. I think that in data science, there's a tendency to say, you know, the model knows all, but in scenarios that I came across in my time doing this in finance, one thing that happens is proxies. So if a customer has a 9-digit zip code attached to their account, by nature, you don't think there's anything potentially like, you know, Equal Credit Opportunity Act violating in that. But if that 9-digit zip code is, you know, a 99% Black neighborhood, you know, it's essentially a proxy for race. And I think one of our teammates ran an experiment recently where even after stripping zip code, even after stripping, you know, ethnicity, marital status, and other, these models are very good at reverse engineering some of these proxies. And the thing too about that is you have to kind of click back to the business questions. Okay, if we deleted all of the kind of, you know, protected class information and neighborhood, why are we seeing, you know, the model predicting, say we want to deny more loans than we want to accept? Then you're actually dealing with the human question of what's going on in the problem set. Like, what data is being fed into there that is perpetuating these human biases? Right? A lot of what kind of I think you're alluding to and what will happen is think about it for credit lending, right? We had a time where redlining loans was a very real thing, where certain people were not allowed to live in certain neighborhoods. And some of that data exists in models. So if you strip out all of the zip code, all of this kind of information, these models can still kind of pick that inference up. And that becomes like the big business question. And it happens to not just with like this case, but with the method of collection of data, right? Like a lot of people farm out their data collection to things like Mechanical Turk and stuff. And you can find very real biases that persist in your model just based on the nature of collection or creation of said data. And I think that's the business question that you have to like really embrace the rigor of and try to figure out what's going on with your company or your actual problem that you're trying to solve, because there might be way more to it.
Great. Well, I believe that does it for all the time we have for questions. I want to thank Nick and Ben for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us today as well. The presentation recording and slides will be made available on our Bright Talk channel later today. And we hope you have a great rest of your day.
Thanks so much, everybody.
Thank you.